So I've told you that lists are the workhorse of Python, and that's true. You're never going to see a Python program without a list in it. But the best feature of Python? Definitely dictionaries. The fact that I can look up a word and figure out its definition at any time in Python, I think that's just fantastic. I'm sure you will too. You're not going to see a Python program that doesn't use a dictionary either. So let's find out what Python dictionaries really are. What is a dictionary in Python? Is it actually a book full of words and definitions? No. It is a mapping. Okay, and this is very powerful in programming. Almost all programs need some sort of mapping where I take keys and I map them to values. And it's a one-way mapping. Each key in the dictionary is unique, and each key has exactly one value. And the way this is written in Python, I can build a dictionary with curly braces. So I can map 1 to 2, 3 to 4, 6 to 727, and 83 to 422. Okay, and you can see this is the key. Then there's a colon, and this here is the value. So when I want to look up the value of the key 1, I will get the answer 2. And a dictionary, so let's say that I said this was D, right? The way you access it, it looks very similar to lists. So D bracket 1 equals 37. We'll set the value of the key 1. Again, this is the key. This is the value. Value of the key 1 will become 37. And this looks very much like indices and lists. So if we had a list that equals, 2, 4, 727, 421, okay, and I access it like this, list bracket 0, okay, I'm going to get the 0th element. This is the same looking syntax as the dictionary. Okay, the key here is 0. Well, that's a bad drawn 0. The key here was 1. Okay, what's the difference? In a list, the indices are fixed, right? The first element is 0, next one's 1, then 2, then 3. If I use append operations, I'll get 4, 5, and 6. So the keys are always numeric in a list, and they always go in order. So I can use the list index function basically to get back the key, right? A dictionary has no such constraints. You notice that I have a key 1, 3, 6, and 83 here. I didn't need to use consecutive numbers. I also don't even need to use numbers. So I can have a dictionary D2 that maps, the string ABC to the number 47. I can even have a dictionary that maps, the string AB to the list 168. Okay, so in many ways, the values can be arbitrary Python objects. The keys are a little bit more constrained. I don't really want to go into too heavily what the constraints on the keys are, but you can use numbers and you can use strings. Okay, and that's probably the most common elements that you'll find as keys in dictionaries. Okay, so why is it called a dictionary? Well, if you think about the key as being a word in your English language dictionary or whatever language dictionary, and the values are the definition. Okay, and so now when I want to look it up, I want to print, what is the value of ABC? I look it up in my dictionary, I find the key, and I find out the value is 47. So this will print 47. Okay, this is really all there is to a dictionary. It's pretty simple. It maps keys to values, but it's hugely powerful in programs. So let's take a look. So I want to show you how to use dictionaries in the context of a very simple cipher program. We're going to take a string of text and we're going to encode it by a simple code that is a one-to-one mapping between characters. So then I can encode it and I can use the reverse process to decode it. So let's take a look at this simple program. Here's my cipher. It's a dictionary, and I'll come back to it in a second, right? And the basic program looks like this. I type in a message, ABC, okay, it prints out, the message is sitting right here, I want to encode it, it says ABC encodes to XCR, I want to decode XCR, so let's type XCR, that's our new message, we type decode, it says XCR decodes to ABC. Okay, this isn't a real encryption program or anything of the sort, right? This is just a very simple substitution cipher where I substitute characters for each other, all right? So here's my dictionary, and this is the actual substitution cipher. This is saying the letter A maps to X, so you can see ABC encodes to XCR. The letter B maps to C, and the letter C maps to R. So there's where our simple code went, okay? When I click the encode button, right, if you look down here, the encode button's event handler is a function called encode, and here it is, all right? What do? Well, I start with an empty string, which is our e-message or encoded message, and then I iterate over the string. You'll notice that this looks exactly like we iterated over lists. So strings are sequences just like lists, so I can iterate over them. For ch in message, we'll go through the string one character at a time, and ch will be the one character string of each letter. So all I have to do here is add to eMessage, so plus equal appends to the end of the string, so it says eMessage equals eMessage plus cipher bracket ch. So cipher is a dictionary, bracket ch says look up the key ch and give me the value of that character, and then let's add it to eMessage. At the end, I print that message, so ABC encodes to encrypted message or encoded message, XCR. And that's all there is to it. I'm simply using this dictionary to transform each character one by one into its value, right? How does decode work? Well, decode's a little bit more complicated, okay, because the dictionary only goes one way. I can't find the key of X with a simple operation, right? So I start with my decoded message, dmessage, then I do for ch and message, and now I want to go in the opposite direction. Well, I've got to find it. So the first character here is going to be X, so I've got to find X in the values. So I can say for key in cipher. What does that mean? Well, I can iterate over dictionaries. So I can iterate over lists, I can iterate over strings, I can also iterate over dictionaries. And when you iterate over a dictionary, you get all of the keys in the dictionary. You don't have any guarantee of what order you'll get the keys, but you'll get each and every key exactly once in the iteration. So this is going to give me all the keys in the cipher dictionary. And here I check, is the character in the message the value that corresponds to that key? If the answer is yes, I'm going to add the key, right? Because now I'm going to add A. If I find X as a value of A, then I want to add A to the decoded message. And eventually you can see it will print XCR decodes to ABC. Now this is a little bit awkward. I have to index the dictionary here. Python provides another nice way of iterating over a dictionary. You can go over the items of the dictionary, and now you have key comma value. You have the key and then you get the value. So I don't have to index it again. And if I do that, it will still work. Let's just run it to make sure. Okay, let's decode XCR. Decode, and it says XCR decodes to ABC. Now this isn't really meant to be a good cipher, it's just a simple substitution cipher, but it is particularly bad in the sense that I don't even have all the letters mapped here. So I want to show you how to make this slightly better. Okay, let's create a string that has all the letters in it. And the Python convention is that when you have something that is a constant that you're never going to change, it should be in all capitals like this. Now let's also now define an init function. And in this init function, I want to create a random cipher. So let's do the following. Let's say letter list equals list letters. Okay, let's import random up here. Let's say the following, that random.shuffle letter list. So what's this going to do? Now I have a list of all the letters. I randomly shuffle them, so they're going to be in some arbitrary order. And now let's put them into the cipher. So the cipher here, instead of having some silly 5 initial values, let's start it out empty. Okay. And what I want to do is I want to map A to whatever is first in this random list now, this letter list. So let's go through the letters for ch in letters, and let's say cipher ch equals letter list dot pop. So I'm just going to pull them off one by one and create a mapping in that way. Now I have a more complete substitution cipher that at least has all of the lowercase letters. Oh, I better call in it somewhere. Let's call it down here. And so it's not going to be, and it's also randomly generated. So it's not going to be great, but I can at least type my message. Python is great. Notice I can't use spaces because I didn't actually put spaces into the thing. Let's encode Python is great, and we get this thing. Right? Looks good to me. Must be the correct encoded value, right? All right, let's try to decode that. Toss it in here. And decode, and it says decodes to Python is great. Okay, this is not meant to make you feel like we're building a better cipher, but I want to show you I can convert lists to strings to lists. I can randomly shuffle these lists. I can iterate over a string. I could have iterated over a list. I can set a dictionary as I go. I can use list pop methods. So I think that this simple exercise here should illustrate many of the things that we've been talking about this week. You're not really going to need to use dictionaries very much in the mini projects in this class. You might use one or two. But the dictionary is a very important tool to have in your toolbox as a Python programmer. It allows you to very easily map values from one to another. And this can be invaluable in certain types of programs. We saw it in action in a very simple substitution cipher, but that's just scratching the surface of what you can do. So keep it in mind, if you have a situation where you have to map one thing to another, a dictionary might be the right choice.